the insula is a very fascinating region because it has privilege. It's very privileged to having information coming in about the brain, what's going on inside the brain, the thoughts and the feelings and so forth, the different brain waves, and the body. So it's getting information from the physiology. My heart rate's okay. I'm okay right now. My breathing, the depth and rate, I'm okay right now. But what if you're not? What if I'm just sitting here, or you're just sitting around, not doing much physical activity, and your heart rate's jumping, and your breathing's kind of, the rate and depth is kind of off. You might register, oh, something's not right here. Well, that's feeding up to the insula to inform the rest of the brain, something's not right here. And the insula is also getting information from the environment. So, three main data sources to pull from: the brain state, the body state, and the environment. How is the living organism incorporating all three of those? So the insula is a very fascinating little region here. And it's right here. This is the frontal part. And then the posterior part kind of expands this way. Now the insula is very lateral, okay, and especially in comparison to the ACC and all of these other subcortical areas that we'll go over. It's very lateral. It's more likely that it came on board later in the evolution. This is also known as a gatekeeper and task switching. So one thing that's fascinating about the cingulate cortex is, and it doesn't matter if it's the anterior, the posterior, the subgenual, whatever. The cingulate, let's imagine these are white fiber tracks, nerve fibers, or so forth. Okay. Remember, we've talked about things like the fasciculi and things. These nerve fibers, myelination, and so forth. They connect brain regions, distal brain regions. We'll go over the mini columns as well because spindle neurons are heavy in layer 5B. But the cingulate, and I learned this from Nolan Williams, MD, PhD, just passed away. Very, very, very brilliant researcher. Huge with investigating depression and things like that. So hopefully his soul is resting in peace. But the cingulate wraps around white matter tracks, like this. Okay, so it's just wrapping around white matter tracks, and that gives the cingulate a lot of access, a lot of fast acting access as well. So the insula and cingulate cortex, it makes sense why it's really involved in these kind of fast acting, rapid transmission type of social bonding type of neuron. Okay, so if you remember, we've covered a network, the so-called salience network. These two regions are essentially the main regions, the hubs of the salience network. So this is a big thing. The salience network allows us to divide our attention. What are we going to pay attention to? What is most important to the living organism? Okay, so you have the ACC and interior insula, and then you have all of these subcortical areas. Things like the ventral striatum, which is mostly the nucleus accumbens. The nucleus accumbens is a very large region, to be frank. The thalamus, of course, the hippocampus, the substantia nigra compacta. Remember the episode with Parkinson's and the basal ganglia? The substantia nigra compacta is dopamine. The reticulata, which is kind of, it's like a Nike check almost. And the check part, the part that comes up, is the reticulata. And then also the VTA, the ventral tegmental area. This is dopamine. So these two are dopamine areas. And then the amygdala and the hypothalamus here. So the salience network, these are mostly the hubs, and these subcortical areas are kind of nodes, what's called nodes. So collectively, these are kind of all working together to help the living organism send our spotlight of attention to whatever we find most salient, salience network. And then also the spindle neuron